Welcome to the channel. Our today's subject of discussion is another very important test related to motorcycles, scooters, and power operated cycle, and that is braking test. To conduct this test, preparation and setup procedure is as follows. Number one, ensure that the test course is level, it is dry, and it is clean. Number two, calibrate all measuring instruments. Number three, confirm that the vehicle condition, that is its tire, braking system, is standard and roadworthy. Number four, place measuring equipment, including stamping devices or optical sensors, correctly. To conduct this test, rider and vehicle classifications are as follows. For vehicles less or equal to 50 cc, with one rider, the recommended test speed is 20 km per hour. Again, with one rider, the recommended test speed is 35 km per hour. For vehicles more than 50 cc, the recommended speed is 35 km per hour with one rider and 35 km per hour with two riders, and last but not the least, 50 km per hour with one rider. Please ensure that the initial speed should be measured just 4 meters before the measuring point using a reliable speed measuring device. Here is the illustration indicating the initial speed measuring area. Now, how to run the test? To start with, accelerate the motorcycle and scooter to the specified speed with the following given tolerance. If it is 20 km per hour, the tolerance would be plus minus 1 km per hour. If the starting speed is 35 km per hour, the tolerance would be plus minus 1.5 km per hour. And if the specified speed is 50 km per hour, the tolerance would be plus minus 2.0 km per hour. As the foremost part of the front wheel crosses the start of the measuring point, a hand flag signal would be given. Apply the brakes immediately upon signal using normal hand-foot operation or a stamping device if required. Thereafter, measure the distance between start of the measuring point and the position where the foremost part of the front wheel comes to a complete stop. For stamping method, measure the distance between the two stamping marks. Remember, stamping equipment is any device or tool used to create physical marks on the ground on the test track surface, and stamping marks are the physical or visual indicators left on the test course during the test to record critical events. Now, how to correct this braking distance? When you have measured the braking distance, which is LM, that we call measured braking distance, then use the following formula to calculate corrected braking distance, that is LC. LC is equal to LM, multiplied by Vs divided by Vt whole square, where Lc is corrective braking distance in meters, Lm is measured braking distance in meter, Vs is specified speed in kilometer per hour, whereas Vt is the actual or what we call true speed of the test, that in kilometer per hour. After calculating Lc, this would be used for further calculations. Now, when we have calculated corrected braking distance, we need to calculate speed retarding rate. Speed retarding rate is equal to B is equal to Vi square divided by 25.9 multiplied by Lc, that is a corrected braking distance. How we have arrived this formula? Now, how we have derived this formula of speed retarding rate B? Speed retarding rate B is equal to Vi square divided by 25.9 into Lc. And why the factor 25.9? We know from our subjects of engineering and physics that kinematic formula A is equal to V square divided by 2D, where A is acceleration, V is the speed in a kilometer per hour, D is the distance. Now we focus on V. To convert V from kilometer per hour to meter per second, we have to use the conversion factor, that is 1000 meters is equal to 1 kilometer, 3000 seconds is equal to 1 hour. Then we substitute this, then we recalculate A by converting the unit of speed from kilometer per hour to meter per second. We get A is equal to Vi multiplied by 1000 divided by 3600 square divided by 2 into distance, are now corrected braking distance designated as Lc. Or A is equal to Vi square divided by 25.92 multiplied by Lc. Or V is equal to Vi square divided by 25.9 multiplied by Lc. This is the same formula except that A is replaced by B, where A in this case was acceleration, but since we are stopping the motorbike or scooter, that is deceleration, so we shall replace A by B. Therefore, B is equal to Vi square divided by 25.9 into Lc. This formula is quite, but this is very accurate and is widely used and is considered as a standardized, and it is always used whenever we do braking test, posting text, and in a straight line. After calculating speed retarding rate B in meter per second square, we need to calculate another important measure which is known as braking effectiveness, and it is very, very important. Braking effectiveness E is equal to B upon G, where B is speed retarding rate in meter per second square, as we have calculated before, and G is 9.8 meter per second square, that is the gravitational constant. This would be a dimensionless factor. What is the significance of braking effectiveness? It is important because it is widely used in safety regulations. It is standardized across all categories of vehicles, that is, cars, scooters, and trucks, etc. It indicates how well a vehicle can convert its kinetic energy into braking force. How can we interpret braking effectiveness E? If the braking effectiveness value E is from 0.70 to 0.80, it indicates good braking performance. If the value is from 0.5 to 0.6, it is acceptable for light vehicles. If the value is less than, say, 0.3, it is a poor performance and it may fail the safety regulations. Braking test, an example. Suppose we conduct braking test on a scooter of more than 50 cc engine capacity. The test details are vehicle type scooter over 50 cc with number of riders as 1. Specified speed is 35 km per hour and the actual or measured speed is 36.2 km per hour. Measured braking distance LM 9.8 meters. Then first we calculate the corrected braking distance LC. LC is equal to LM Vs divided by Vt square, where LC is corrected braking distance, LM is measured braking distance, and it is 9.8 in our case. Vs is specified speed, Vt is true speed or actual speed. By substituting these two values, we get corrected braking distance is equal to 9.8 into 35 divided by 36.2 whole square, and by simplifying this we get corrected braking distance as 9.16 meters. Now when we have calculated LC, that is corrected braking distance, we can calculate speed retarding rate B. B is equal to Vi square divided by 25.9 multiplied by LC. Therefore, B is equal to 36.2 square divided by 25.9 multiplied by corrected braking distance 9.16. After simplifying this, we get B, that is speed retarding rate, is equal to 5.51 meter per second square. Now, when we have calculated B, we can calculate E, that is the braking effectiveness. E is equal to B divided by G, that is equal to 5.51 divided by 9.8 is equal to 0.56. This graph shows the relationship between corrected braking distance LC in meters related to initial speed in kilometers per hour. With the increase in initial speed in kilometer per hour, the corrected braking distance LC also increases. It shows the relationship is almost linear. Now, why braking test is important? It's important because it evaluates the motorcycles or scooters' ability to stop safely and efficiently under specified conditions. It is crucial for safety, regulatory compliance, and for performance validation. The key objectives of braking tests are ensure the braking system performs reliably at various speeds and loads. Measure how quickly and safely a vehicle can come to a complete stop. Verify conformity with the legal standards and reveal any deficiency in brake design, materials, or maintenance. It helps engineers, manufacturers, and regulators ensure safety for braking performance under real-world riding scenarios. The key utility of braking test is to verify and quantify the stopping performance of a vehicle under standardized conditions and to ensure rider safety and regulatory compliance. To summarize why brake test is so important, let us look at various purposes. Number one, safety assurance. It confirms the vehicle can stop within a reasonable distance to avoid accident. Number two, performance benchmarking measures and compares brake quality across different vehicles, models, systems, or configurations. Number three, regulatory compliance satisfies government or industry standards for certification, etc. Number four, design validation. It assists engineers in testing new brake materials and systems and their performance. Load handling check assesses brake performance with single versus double riders or loaded conditions. Number six, maintenance diagnostics. It helps in identifying degraded or imbalanced braking components. The real-world examples of utilities are it ensures short braking distance for city scooter used in stop and go traffic. It validates that brake do not fade under repeated use, especially in hilly regions. It helps regulate, prevent the sale of underperforming vehicles. Now, why speed retarding rate is important? We know that speed retarding rate is the vehicle's average deceleration measured in meter per second square while braking from a given speed to a full stop. We know its formula that B is equal to VI square divided by 25.9 multiplied by LC. Its significance is it quantifies how rapidly the vehicle slows down. Higher value means stronger, more effective deceleration. Used to compare different braking systems or configurations. It is an important input for calculating braking effectiveness. It gives a numerical measure of stopping power critical for both design and safety assessment. Why braking effectiveness E is important? Braking effectiveness is a dimensional ratio that compares the actual deceleration to gravitational acceleration. We have already calculated that E is equal to B divided by G. It is very important because it provides a normalized value of braking system. It's make easy to compare performance across different vehicles and test conditions. Its interpretation is as follows. If E is near to 1.0, it is excellent. Strong braking system close to 1G deceleration. If the value of E is ranging from 0.4 to 0.6, it is acceptable. If it is less than 0.3, then it is a weak braking system and needs investigations. Braking effectiveness E is a universal performance indicator ideal for benchmarking, design targets, and regulatory compliance. Let us summarize our today's discussion on the subject of braking test, part 1. Braking test, it assesses overall braking system performance and safety. Speed retarding rate B, measured in meter per second square, it measured deceleration rate, or what we can say reflect stopping strength. Braking effectiveness E, it is a dimensional ratio. It is normalized performance index for easy comparison across tests. With this, we conclude our today's discussion on the subject of braking test for motorcycles and scooter, and it was part 1. Our next topic would be braking test for motorcycles and scooter, part 2. Please do drop your comments and share your experience. And stay tuned and don't forget to like, share, and subscribe to receive the similar contents in future also. Thank you and thank you very much.